Okay, so I've got everything set up for your test. And what I am doing is going to have it's going to be sort of timed. You're going to have 3 hours to take a test that normally you would have an hour and 15 minutes to take. So it's double the time. It's also set up to where you can take it starting anytime from 12:30 on until I think at 9 o'clock at night, right? So as soon as you start the test, though, you have 3 hours to finish it, right? That makes sense, everybody? Any questions?
No questions.
No questions or yes questions? Yes.
Nope.
I've got some questions that I have someone sent me, and so I will I've got them flagged in here. And I'm not sure which class it comes from, so I was going to just go ahead and do them for everybody. And I thought I had it flagged. Okay, so I've got several people asking the same questions. So I'm going to share my screen first of all. And before I'm going to get out of here. Is everybody still there?
Yes.
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 Okay, good. I thought I lost y'all. All right, so this one comes from Darian, and there's asked the same question. I had an Excel spreadsheet set up where I worked the problem already. I'm going to just do it from, I don't know what's going on with my screen. I'm just going to open up an Excel spreadsheet new, and drives me nuts. Okay, so the question says, and let me get my board all. It says you need a 30-year fixed rate mortgage to buy a new home for $180,000. Your mortgage bank will lend you the money at 7.1% APR, which stands for annual percentage rate. That is your R in our equations for this 360-month loan. However, you can afford monthly payments of only $950. So you offer to pay off any remaining loan balance at the end of the loan in the form of a single balloon payment. So the question is, how large will this balloon payment have to be for you to keep your monthly payments? So this is actually not that bad of a question. It seems like it, but the way I would approach it, and there may be easier ways, but my way of approaching it would be to develop an amortization table. And so the idea here is, and let me get Excel out. Okay, so I'm going to blow this up. And I'm going to set up an Excel spreadsheet which has time the payment made, the interest rate, the principal paid to the loan, and the balance. All right, and they said this is a 30 year, which would be 360 months. So I'm going to set up a column that's going to have every single one of my payments out, 365 of them, or sorry, 360 of them. That would be 30 times 12. So if anybody's interested in getting a long mortgage here, that took a little while to get all the way down to our very last mortgage payment. A lot of payments there that are obligated. Now the loan amount to begin with is $180,000. I put that on my row, which is 0, time period 0. I'm basically getting everything set up on time period 0. My balance, my payment that I can make is actually $950. $950 I'm going to put in there, right? Now over here on this side, I'm going to look and see, well, how much would my payment be? And I'm just going to kind of get this in my head. How much should my payment be on this loan if it were fully amortized? No balloon. My interest rate 7.1%. I'm going to divide that by 12 to make it monthly. My number of periods is 360 months. My present value is $180,000. And my normal payment, if it were fully amortized, would be $1,209.66, just to give you an idea. I can't pay that though. So I've reached out to the bank and I've said, well, I can't make that $1,200 payment, but I can make $950. So how about if we do this? I make a payment of $950, and then at the end, that means in month number 360, there'll be a balloon in which I will then pay off or refinance, one of the two, right? So I'm going to figure out now, how much interest do I owe? And this is on my first month's payment. I'm going to owe 0.071% multiplied by my current balance. And I'm cell referencing that current balance because I'm going to have 3 equations connected here that I'm going to copy down. And I want that to copy down with it. And I don't want it to be fixed. I need to divide that number by 12 because we're working in months. And so that very first month, I'm going to owe 1/12 of the year's worth of interest, right? So that first payment actually is $1,065 in just interest, right? I'm only paying $950 to this. That means that this is what we call a negative amortization loan, meaning I'm not even paying the interest owed monthly, meaning I'm taking out an extra loan as we go here. So my principal is going to be my payment, and I'm going to freeze to it. I'm hitting Command T on a Mac. You guys would be hitting F4 if you're a Microsoft guy that's got a normal, computer, not non-Mac computer. So I'm freezing, putting those dollar signs on this cell B2, which is my payment, which is going to stay the same. I'm going to subtract from that my interest, which is $1,065. It means I'm taking out a loan of $115 a month with this structure that we're looking at. All right, so when I go over to the balance, I'm going to hit equal. My balance is going to be my previous balance minus my principal. But I'm doing a minus, it's actually going to be adding to my balance, right? Now, once I have it all cell referenced, I'm going to take this all the way out to 360 months. And this is going to be ugly because that balloon after 360 months is going to be big. All right, so at the end of 360 months, I need to put commas in here. You can see here that my balance is growing. And in fact, by the time we get down here at the very end, my balance has grown to that I owe not $180,000, but $323,096.66 to be exact. So the balloon that I would owe is bigger by more than double what I borrowed to begin with, or somewhere around double. Make sense to everybody? Any questions about how I solved that? And the idea here is look at that principal. It's actually, you're borrowing money. You're not even, with a $950 payment, you're not even covering the interest owed. This is the way a lot of credit cards work as well, by the way. So you have a minimum payment. I think we did that in class, a minimum payment, and it doesn't, and some credit cards don't even cover the interest that you owe, meaning that if you don't put $1 more charge on your credit card, your balance still will grow over time. And this is a negative amortization type of loan. You can also call it a balloon payment type of loan. And it's just where that principal that you're paying, in this case, we're not paying, we're actually borrowing. We're not paying off any principal here. But when we came up with that payment that was 1,200 some bucks, 0.071 divided by 12 over 360 months, and the present value was 180. That value there, $1,209.66. So if I put that in here, 1209.66, we're going to get a little rounding error, but this is fully amortized. If we pay $1,209.66 every month, then when 360 months rolls by, whoops, we're actually going to virtually owe nothing. And the reason why that's not zero is because I rounded, right? So I didn't actually put the equation straight into that payment cell. Instead, I did it off on the side and then I rounded it. So if we'd been paying $1,209 for 30 years, we'd have all the principal paid off, but we weren't paying. So our deal is that we were paying something less. The number was $950. And you can see there's no principal being paid off, and that balance just grows. And that's why we call it a negative amortization. Instead of being fully amortized, where you've got the principal that's actually spread across the life of the loan, we're actually borrowing, starting out $115 extra a month. But when you get down into the 30th year, that monthly loan that you're getting is getting high. That last one, you're getting a loan of $956 a month. And that's why by the 30th year, you got a big balance yet to pay off. Does that make sense to everybody? Two people asked that question. The other person asked the same question, but it's an algorithmic homework assignment, so everybody has different numbers. But that's the way I would solve it if it were me. Okay?
I have a question from Connect.
Okay.
I posted it in the chat. I don't know if you can see it or not.
Let me look. Might have to stop sharing. Okay, so you have a 15-year annuity of of 30 $11,000 semi-annual payments that are going to begin 10 years from now. Okay, so that a lot of information here in that first. So 10 years from now, and in fact, actually, this is all in semi-annual terms. So I'm going to put my time frame here, 10 years from now, which is 20 semi-annual periods. That's 10 years, right? And at that point, you're going to receive a 15-year annuity of 30 semi-annual payments. All right, so that means we've got to go all the way out here from, this is 10 years. We're going to have 15 more years. So that means 20 up to 25 years, which would be 50 semi-annual periods. And you're going to have, between these two dates, 30 semi-annual periods. And in that 10th year, you're going to be receiving $11,000, and it's beginning 10 years from now, with the first payment coming in 10 and a half years. So this is 10 and a half.
Dr. Lewis,
Yeah.
how did you get the 30 semi-annual periods in between 10 years and 25 years?
So it's 30 semi-annual payments of
But it already said, but it says 50 semi-annual periods right there.
50 where?
So in your timeline, right there in the end, you've written.
I'm going here from 0. This is 0. 10 years is here, which is 20 semi-annual.
Oh, okay.
And then I'm going out another 15 years, which gets me to 25 years, which is the 50th semi-annual payment. Does that make sense?
So the 50 semi-annual payments is not between the time frame from 10 years to 25 years?
No, that's 30 right there. Between the 10-year mark and the 25-year mark is a total of 15 years and 30 semi-annual payments. Does that make sense?
Okay, I get it.
And they say you start this annuity at the 10 and a half year mark. Well, that's this mark right here. So right there is the first $11,000 payment. And you're going to get 30 of them all the way out here. And the last one's going to end up in the 50th semi-annual period payment. Does that make sense?
I think it does.
Okay. All right, so if the discount rate's 7%, so 7% interest is the interest rate across the board. Compounded, oh goodness gracious, compounded monthly. What is the value of this annuity 5 years from now? Okay, so here we got a problem, and this is really hard, and I didn't teach you how to do this. So you don't have a test question like this at all. And the reason why this is hard is because you have semi-annual payments, but you're asked to actually compound monthly. Does that make sense to everyone?
Mm-hmm.
That is something that you can't handle immediately. Best way to do that, and I'm just telling you this just for your own reference, this is not going to be on the test, but it's compounded monthly. What's the value of the annuity 5 years from now? So there, this is so complicated. 5 years from now is at the 10th semi-annual period. So that's where they want you to value it at. And again, there's 10 semi-annual periods between the point in which you're going to first find the value at time period, what is 20? And then you're going to have to take that lump sum and bring it back to time period 10, which is the 5th year. And the trick here is to use the right interest rate, because you've got two different interest rates. You've got one that's an APR, but you got another one in which is your EAR. So you first have to calculate your effective annual rate. And your effective annual rate is equal to 1 plus your APR, which is 7%, divided by the number of times compounded, which is 12 times per year, raised to the 12th power. And you're going to subtract 1 from that. So you're going to get an interest rate. So you're going to plug that into Excel. And let me share my screen again. So your EAR is going to be equal to 1 plus 0.07 divided by 12, all raised to the 12th power. And then we're going to subtract 1 off that. All right, so EAR is something I gave you the equation for, but we didn't really talk a lot about it. EAR is an adjustment to your rate for compounding. All right, so you could have two banks. One says your interest rate is 7% compounded monthly. Another one's going to say your interest rate is 7%, but it's going to be compounded semi-annually. They're both stating the same APR, but they are not the same effective annual rate. So this equation right here, your EAR, is making that adjustment for you to equate them. An APR, an annual percentage rate that's compounded annually, 7%, is effectively, if you were instead going to compound it monthly, is 7.229008%, right? All right, so that's the first thing that's hard, is that you've got to convert to an EAR. Second thing that's hard is that you've got these semi-annual payments and actually figuring out where are you going to value this annuity at. First off, you're going to value this annuity at time period 10. You're going to treat it like an ordinary annuity. And the ordinary annuity is going to be equal to present value, open parentheses. You're going to use that EAR, right? That's your effective annual rate. But you're going to do this semi-annually now, because now we're working in semi-annual terms. That's M is 2. And then your number of periods is going to be 30, which is 15 years of semi-annual payments, and your payments are 11,000. And your type of your annuity, we're going to set to be equal to 0, which means that you're going to value one time period behind your first payment, which comes in year 10 and a half. That means you're valuing at year 10. You're going to get a number, all right? We got 199,441, but they don't want the value at year 10. They want the value all the way back here at year 5, which is at period 10. So we're going to take that number and we're going to do another present value. The rate is going to be 0.0, and I'm going to actually cell reference because we're going to have some difficulty with the rounding here. I'm going to divide it by 2. Number of periods here is 10. 10 semi-annual payments between these two dates. There's no payment, and we've got a single lump sum present value. And so I would value that right now at 139,832.80. And there is no way I would ever ask you a question like that on a test. No way ever. Make sense to everyone?
The second part of the question also asks, what is the present value of the annuity?
As in time period 0?
Yeah,
Yeah, so all you have to
the
do,
current value.
yeah, so all you have to do is bring it back all the way to time period 0. So you can still use that future value of 199,441.06, which is the value here at time period 20, and just bring it back 20 time periods instead of 10. So instead of having that number as 10, we go 20, not 230, 20. There we go. Does that make sense?
Yeah.
All right, so that one is hard on so many levels. One is the fact that you have to convert. You've got this problem with you've got semi-annual payments, but they are being compounded monthly. That is the first problem, in which you correct that by using an effective annual rate. That's why I converted our APR 7% into an effective annual rate, which was like 7.22%. Everything I did, I tried to cell reference, because you see that rate is really, it's a long interest rate that's, we could round, have a lot of rounding error if we don't actually cell reference. And then once you do that, you've got to find the present value of this annuity, which is 30 $11,000 payments. And when you find that present value, you've got to know where to put it. And it's right there. One, because we treated it as a ordinary annuity. This turns into time period 0. This is 1, 2, 3, 4, 5, out to 30. And so we're anytime you got an ordinary annuity, when you take a present value, you're finding the present value one time period before the payment starts. So the payment starts at the end of that first year, right? We could have done this as an annuity due, and if we had, our value that we would have gotten when we put in type 1 would have been right here at time period 10.5, right? Once you have this lump sum that we got, and we got 199,441.06, then you can bring it back anywhere. You can move it along that timeline anywhere you want it. The first one you asked me for was at time period 5 years, which is 10 semi-annual periods. And then the second question was to bring it all the way back home to time period 0. And so it's easy once you've got it converted appropriately to one point on the timeline. Does that make sense?
It makes sense, but I have another question about it.
Yeah.
What type of annuity would behave this way? And then present value, would you be trying to determine that, for example, if you wanted to sell it to a company that buys annuities?
So these are details that are important, when you're calculating present values, to take note of. But I'd say 99 times out of 100, the assumptions about compounding are aligned with when the payments come. All right, so 99 times out of 100, it's going to be, if it's a monthly payment that you're purchasing, it is going to be compounded monthly, right? If it is not, if it's something complicated, you need to convert it into an EAR first before you just willy-nilly go throw in the APR into your equation. It won't be right. Does that make sense? So you've got to convert to EARs. I was talking to Dr. Cresson, who's a faculty member at Southeastern, and he actually teaches right before you guys used to come into your real class. His son is getting a finance degree at Notre Dame. And at Notre Dame, they actually just inherently don't even talk about APRs. They don't even though that's the way you see whenever you're quoted an interest rate, whether it be a loan or an annuity, you're always quoted an APR. That is just standard on most contracts. But at Notre Dame, they were basically just skipping over this idea of an APR and going straight to an EAR, and then you would use EARs for all their calculations. And John said, well, you know, that makes sense. I understand why they're doing it. My kid didn't have any idea why they were doing it. He could do the math, he could get the answer right, but he had no idea why the answer was right. And so, I think he thought that it was going to be a problem going forward. His kid's real smart. He wouldn't be at Notre Dame if he wasn't, but his kid's real smart. He can figure out like how to get the right answers, but explaining why he got them is another deal. And he couldn't explain why. And so this idea of an EAR is a conversion. That's what it is. It's just a conversion so that you can account for compounding. And we've got two different compounding possibilities here, monthly and semi-annually, all in one problem. So that's, would you come across this very often? I would suspect not. But if you did, could you handle it? I hope so now. Any other questions? No?
I have a question. So in this problem, even though all the transaction occurs from year 10 all the way to year 25, why did we use the 7% rate that was given? We converted that into EAR. And why did we use that percent even though we are talking about year 5? Because technically transaction has not started and that percentage has nothing to do with the value in year 5.
So you get it from period 20 to 50, right? Why we use EAR? Once you use that EAR that you're assuming, you still got semi-annual periods, but the problem has told you that you're compounding monthly, all right? So that's set. By the way I read it, and it is a little bit confusing about this, but I assume it's being compounded monthly from time period 0 all the way to time period 50. Now, if it were not, if it were being compounded semi-annually between time period 0 and time period 20, you could use that APR.
So
right?
Does that mean even though there's no money from time period 0 to time period, 10, that is still going on a semi-annual compounding basis?
Yes.
Okay.
So that's what would happen. You would be assuming semi-annual compounding if you took 7% and divided it by 12 and plugged it into your present value calculation, when the problem clearly states that it's compounding monthly.
Okay.
That's the reason.
Haven't we seen, like, I know we haven't seen one like this, but are there questions like this that basically state the value of the annuity? Like you're receiving $1 million annuity that's going to start paying out in 10 years. I mean, I think that's what's confusing, at least for me, about this question is like, I don't know, the total value of the annuity is not there. So it's like, do you think that nothing's happening in those first 2 years, like was just stated?
Yeah, but the thing is that this would be like my situation. If interest rates were really high right now, which they are not, so because they're so very low, I'm uninterested in looking at annuities. But if interest rates were to go up high, that's pushing the present value down, makes them cheaper. So let's say I wanted a $50,000 a year annuity, but I'm not really, I don't need those payments today because I'm working. I don't want them. I want to push them off for 10 years. I could still purchase that annuity today. It just wouldn't start paying me for 10 years. Does that make sense?
Yeah, that makes sense.
Yeah, so I would be a good example of that. If interest rates were high, if there was a time period where interest rates spiked up and I was excited about maybe capturing a cheap annuity so that I could more reasonably, more safely retire with this certain income in the future, I wouldn't want the income coming to me now, but I might want it in 10 years. And if there was the opportunity that, arise because high interest rates, I might find them cheap and ready to buy. And I need to know what the value would be today. Does that make sense to everybody? Now, oftentimes, what you'll get in reality is you'll get insurance companies sell these things. These insurance companies will tell you what your payments are, all right? and this would be a simple one, where your payments are going to be $11,000, let's say every 6 months. And they'll tell you how much it costs today. So they will have given you the $98,040. And then the interesting thing for you to do is this a good deal or not, is to back out the interest rate that's being implied there. Because it's really, people say, well, and these annuities, they're bad deals. You even see commercials about that. And annuities are bad deals. No, you shouldn't buy annuities in general. And there's thousands of annuity products. And so I don't like to say that blanket, annuities are a bad thing to buy. They're bad investments, because I think it's individually, and you want to know what kind of rate of return you're going to get relative to the market, right? So if the interest rate that it's implying is higher than what the market is today, hey, they might be a good deal. That might be a good deal. Now, the reason why people typically will say, and you see this on commercials, that annuities have a lot of hidden fees, and that's absolutely true. They'll tell you what you're going to get, but they don't really tell you how much you're paying for sure. It's like there's a lot of hidden fees, and they're high fees. I have a student that she's been graduated about 4 years, and she sells annuities. And I had her come into class one evening. She popped in to see me. She came into class, and I introduced her to the class, and I told the class what she did. She sold annuities, and she was basically promoting the fact that she made a lot of money on these annuities. Up front, if she could sell somebody an annuity, she made 11% off of the present value. That was her commission, right? And I'm sitting there thinking, don't say that. If you're trying to sell an annuity, you don't want to be telling them what your commission is. It's a huge commission. And so it was really a good deal for her. But my husband and I, we have a joke that if anything ever happens to me, and I know that Hannah Marie is going to come directly to DEC and say, you got to buy an annuity from me now. And he says, I'm going to turn around and run, because I know she's getting a really high commission, for it. So it's not the idea of an annuity that's bad. It's typically the hidden fees that are bad. You really got to be really cautious when someone's selling you something. And understand what you're going to get, when you're going to get it. These annuities can be extremely complicated. What we're doing in class is simple, flat annuities. They've got annuities that will grow with the market. They will grow with inflation. You've got all kinds of little mechanisms that they're no longer flat payments. They'll still call them an annuity, but they're no longer flat payments. They're a flat payment that then they add to it some sort of cost of living sort of adjustment. And it might come in the form of it's moving, the payment is rising with returns in the equity markets, or to some index, or to some inflation index, something like that. But they are quite complicated. And so, don't be afraid if you're looking into buying one of these things to just get your old little timeline out. I don't know how many times I've done that. And, I figure out what they're trying to sell me, and I try to figure out, what am I really paying and what am I getting here? And try to figure out exactly the cost to everything, so it's, they can be, I don't want to say deceiving, but it like anything, there can be hidden fees. Mortgages have fees up front. They're called closing costs. It's not captured in the APR, right? And so you pay, like I'm refinancing, I'm paying $3,200 to refinance. In order to get an interest rate that's 2.8%, I'm having to pay up front what I consider interest. It's cost to me. The bank considers it a fee. I consider it interest. Doesn't really matter what you call it. It's something that's out of my pocket, right? But I'm paying $3,200 in order to refinance, and that's not being captured in the APR. That's not being captured in that 2.8%. Any other questions? Okay, I had some others here that I had flagged in my email. And I think someone, it was Savannah Pinner, and I don't know if she's actually in your class and here or if she's in the next class, but it says consider a firm with a contract to sell an asset for $145,000. Okay, so it says, consider the firm with a contract to sell an asset for $145,000 4 years from now. All right, and the next thing is the asset costs $91,700 today to produce. $91,700. The relevant discount rate is 11% per year. That's an APR. What's the firm's profit on this asset? Okay, so we've got a time frame here. It seems like everything's filled in on our timeline. You know, doesn't it to you guys? It's like, well, what's the question? I don't know what the question is. Well, the profit is going to be, what is the present value of this thing we're going to sell? What's the present value today? And then we're going to compare it to what it costs us today, right? So in reality, this $91,700 doesn't matter to us yet. We want to first find out what the present value of the benefit is, and then we'll subtract the cost off of it from today to get the profit. So this is a relatively simple, straightforward present value calculation. It's going to be equal present value. Interest rate's 11% annually. The number of periods is 4 years. So everything I plugged into Excel is in annual terms. There is no payment. And then the future value is $145,000. So that means that the present value of this asset I have here today is $95,515.99. All right, and I'm going to just subtract from that what it cost us. So I'm going to hit a minus sign here. There's my benefit in today's terms. I'm going to subtract from that my $91,700. So I get $3,815.99. That's my profit in today's value. So you can see this is the benefit, all right? And in present value terms, this is $95,515.99 of benefit. And then it gives me in the problem how much it cost, which was $91,700. And it's just the difference between the two. So all we're doing is bringing numbers back to home, time period 0, and subtracting the costs from the benefits. That's all we're doing. The next part of that question, it says, at what rate does the firm just break even? All right, so break even, and they're asking for a rate. And equal, we're going to say rate. We got 4 years, all right, in this time frame. There is no payment. The present value, it's costing us $91,700, and the future value is going to be $145,000. Whoops. Okay, so that rate that it produces for us, 12.14%, is going to be our break even. So if you think about this math here, And our cost is 91,700. So if we're going to look at break even, the rates that we computed, number of periods, 4 years, no payment, 91,700 and 145 is the future value. Our math here is that the present value, 91,700, is equal to the future value, which is 145 divided by 1 plus the interest rate divided by the number of times compounded, raised to the 4 years times 1. And M is 1 here, so I'll just put that in. And we are solving for rate. And that rate is going to be what is our break even. Now, when we get past this test, we're going to be doing what we call capital budgeting problems. And one type of capital budgeting problem is doing exactly that. It's actually what we call an internal rate of return. You're taking your benefits in the future and your present value cost today, and you're finding what the actual rate is. And that is your break even. That's your, that's what makes you indifferent between the two. All right, and that was it. Is there any more? Any other questions about the test? This is, does anybody have a problem? Let's see, let me go to Connect. This is gonna be on Connect.
How many questions are we gonna have in the test?
This test has 22.
And we have 3 hours to complete it
Yeah.
once we open it? Okay.
Yes. So once you open it, you'll have 3 hours. Is there, let me make sure that, let me go on to Connect and see what time frame I had for you. I think I have, I might have done just, I think I got this all set up for my upper level class. And I might not have changed the times on yours. Let's see, you're the 12:30. All right, so down here, you can't see this yet, but I can change these policies. Right now I have it set to where you only have an hour 15, but my intention is to double that. It's to give you 3 hours. Would you guys prefer to have 3 hours starting at your time that we have class until 9 o'clock at night? I was thinking a 10-hour time frame. Is that good for everybody? So it'd be like from 11 all the way till 9 o'clock at night, or you guys are 12:30, so maybe till 10:30 at night. Anybody have any problems? Okay. So what I'll do is I will edit this, and I've got you set up, and I'm dealing with several different kinds of software, and I can't remember if this one I might not be able to do this on yours. Actually, I don't think I can. I've got other software where I can put in a range, and as soon as you start, it's 3 hours, but it doesn't look like McGraw-Hill's letting me do that. So how about if I start it at our time at 12:30 and then have it do 3 hours later, so at 3:30. Is that good for everybody?
I have a class right after this class, so I have another class at 2.
Okay, and they meet, so what about do we want to do it earlier? So it's, say, between 11 and, say, 2?
That would work for me. I don't know if it
What
works for
everybody
somebody else.
else? Anybody else have a problem?
I have
At 11.
before that. Could it be from like 3:30 to 6:30? Would that work or no?
3:30 to 6:30? Speak up, everybody.
That would work.
30 to 6:30 works for me.
Okay, all right. So if we set this at 3:30, And then we end it at 6:30. Yeah, the other software, I could have an entire long period where as long as you started it, sometime in that period you had 3 hours, but it doesn't look like McGraw-Hill lets me do that. Okay. All right, so I'll post that up on Moodle. So if you also have friends that might not be coming to class or watching the videos, I'm going to post it up on Moodle. Let everybody know too, if you know someone that's might be confused about that, because I have said earlier that it was gonna start during class time. But since I'm going to make it 3 hours, I honestly don't think it's going to take you even an hour and a half. All right. I'm just getting guidance from the dean and others, administrators that say that some of you are in tough shape as far as your facilities that you're having to use, and things probably will take longer. So I'll go ahead and post that and let you knock yourself out. But it's pretty straightforward, and it comes straight out of Connect, and you shouldn't have any problem, I don't think. Right? Now you will, I only have it set to where you can take it one time. All right, so it's just a one-time shot, but it's going to be basically just like your homework. All right, any other questions?
Nope.
All right. Well, I will see, I guess I won't see you guys. I won't monitor this. You'll have your book, you'll have your Excel, you'll have whatever open. So it's kind of like an open book test. And it's pretty easy too. So I expect pretty high grades here, right? Any other questions? Well, then I'll let my husband get going with his econometrics class next. If nobody else has any more problems for me or anything like that. And Alvin will put this, you'll send me the link here soon. All right, so Alvin's all over it, and I'll shut you guys down, and everything will be set up for you at 3:30 to get into Connect. All right, adios, good luck, and stay safe.
Bye-bye.
Bye.